Hello everyone, welcome to the video. In this question paper, we will be solving the numerical on information gain and decision tree. So let's begin. So the question given to us is classify the bank loan applications by assigning application to one of the three risk classes. The risk class over here are A, B, and C. The risk class over here are A, B, and C. The total number of examples are S equal to 10, that is the number of frequency of ABCs. The frequency of A is A equal to 3 times, as we can see over here that A has been repeated over here A 1, 2 and 3 times. Similarly, B has also been repeated over here 3 times and C has been repeated over here 4 times. 1, 2, 3 and 4 times. So we need to calculate the overall information gain in this process. So we use the formula I is equals to minus P log base 2 log base 2 minus P minus P minus P log base 2 P minus P log base 2 P. It can be also considered as P1, P2 and P3 in this case. So P1 would be equal to frequency of A divided by total count. So which is equal to 3 by 10. Similarly, P2 would be equal to 3 by 10 as well, and P3 would be equal to 4 by 10. So as we can now we calculate the overall information gain. So I would be equal to minus 3 by 10 log 3 by 10, minus 3 log 3 by 10 and minus 4 by 10 log 4 by 10, which computes up to 1.57. So the overall information gain that comes out to be 1.57. Now what we are going to do is we calculate individual information for each column. So let's do that. For the attribute one, that is owns home column, in this we can see the value of y. The value of y is, that is the number of applicants that said yes, is total 5, and out of 5 applicants there are 1 from A class, 2 from B class and 2 from C class. And similarly for no values, there are 2 values from A class, 1 value from B class and 2 values from C class. And similarly we calculate the information gain from phi from using the formula I is equals to minus P1 log P1 minus P2 log P2 minus P3 log P3 and so on. So here as we can see, the number of values for A that corresponding to S is 1 and the total number of values are 5. So it's minus 1 by 5 log 1 by 5, minus 2 by 5 log 2 by 5 and minus 2 by 5 log 2 by 5. The value comes out to be 1.52. Similarly, we calculate the information for IN, which comes out to be 1.52, and we calculate the total information of the two subtrees, that is y and n simultaneously. So the number of values in y is 5 and number of values in n is also 5. So total it comes out to be 5 by 10 and 5 by 10 each. So it's 0.5 I of y plus 0.5 I of n, which comes out to be 1.52. Now similarly we calculate for each one, that is married and gender. So the final values, as we can see, comes out to be 0.846 and 0.69. for the gender column, and the remaining two are the remaining two are employed and credits rating. The value of overall information for employed comes out to be 1.12, and for credits rating it comes out to be also 1.52. So now what we are going to do is we subtract the overall information for overall information gain with each respective attribute. So let's do it. Now we have seen information before split is 1.57, 1.57 for each class, and for information after split is 1.52, 0.85, 0.69, 1.12 and 1.52. Now we subtract these values, then we get the overall information gain, that is 0.05, 0.72, 0.88, 0.45 and 0.05. So as we can see that the gender column has the largest information gain value. So this would be our root node. So and also we can also see that the class B has almost every gender equal to male. So we can remove class B as all the genders are equal to male in this case, and then we reduce the column to column size, and then we have calculated the information gain again for the reduced column. As now we can see the reduced column has only 1 2 3 4 5 6 7, only 7 entries, and the information is calculated similarly using the formula I is equals to minus p log p. We have used this formula, minus p1 log p1 minus p2 log p2 and so on. So the overall information gains comes out to be 1.33. So the I in this case is 1.33 before split. So now we will calculate information for each attribute. So let's do that. As we can see, there are only two columns left, which is the owns home column and the married column. Now we can see the IY and IN values for owns home is 0.92 and 1, which then the total information of the two subtrees comes out to be 0.96. And similarly for married, as we can see, the information in Y comes out to be 0, and similarly the information in N also comes out to be 0. So the total information for these two subtrees comes out to be 0. Now we don't need to consider any further attributes as these two values are zeros. So it's going to be our next node, which is the married column. So when we subtract the information split before to after, the maximum value would be for married. So we can now just simply draw the subtree. As you can see over here, the gender column is the root node. There are only two genders specified over here, that is female and male. And also we have discussed that the class B has all the male, so the class B comes out into all the male category. In the female, as we can see that the second node is married node. In the married node, the answers are yes and no, and the class C goes in the yes column and the no category goes in the class A. So this is the root node. This is the decision tree for the given data. So this is how we solve the question and compute the decision tree. So this is all in this video. Thank you. Have a great day.